So here's perhaps a very reasonable thing to improve with what we currently have. Uh, the the There's one inconvenient and sort of difficult part to this code is that we have to predict and specify the array size, right? So right here, to accommodate 3 items of different types, we had to say how big the array should be. So this is the limitation of an array that once created, you cannot resize it, so it's not very flexible. So instead of doing this, let me, instead of removing it, just comment this out. Instead, I could use ArrayList, right? ArrayList, which is typically a first choice for straightforward collection of items, and I can declare that this is an array list of products, right? Of a product item, right? And similarly, name it a product. And of course, all I need to do is just say new array list, and use default constructor syntax. Of course, I need to import it, which I will do by cheating and just saying fix imports, right? Which supposed to insert an import statement, and it did. And so then the thing that I have to change is this syntax. The index notation to refer to elements is no longer available. Basically, this is the notation. The index and subscripting is available only in Java, at least in Java, is only available to built-in arrays. Now we're dealing with, a custom collection. So therefore, we need to revert to a method, and the method will be simply most likely add, right? There's an insert, but we can use an add method to add our instances to that collection. So let's give this a try, right? If I'm doing everything right here. Oh yes, thank you very much. I meant to name it products. Yes, yeah, I see what the unhappy part now was. Okay, so here we go. So we can do this, and this is a very little change. But beyond that, I think under most circumstances, the first choice for a collection should be an array list. It's very effective. It's very simple. It has this broad spectrum of all kinds of methods that you can use with it. So therefore, it's very flexible. One thing to remember, of course, is that you still have to create it as new, but then you can populate it, and you can do more things. Like, for instance, you can sort items inside this array, and you can search through the array, and you can insert in the middle or at the end, and so forth. So this is very flexible. So perhaps this really kind of demonstrates the power of both array technique, which has this limitation that you have to know how many elements of an array you need, or dynamic array such as ArrayList, which basically grows as you add elements to it. As necessary, it will expand and provide more space to accommodate new elements in it. But both demonstrate the power of this abstract method such as full description. So it just simply says, okay, if you have this hierarchy of objects and you rely on the fact that there is a method provided to product, and the method has a set of parameters. In our case, there's no parameters, but it's still a valid set of parameters to have a method with no parameters, a specific return value, then you're perfectly fine in terms of, using the interface of this product class in a situation when you have to deal with collection. So let's just give a very quick demo. On this one, it pretty much behaves exactly the same way, right? It's predictable, it's expected, and it does work. So once again, if this runtime behavior with abstract classes and the hierarchical relationship between classes didn't exist, I don't know how, the only choice for me would there be that I would have to create a separate array list for books, a separate array list of video games, and if tomorrow I need another class to this application, I would have to create another array list, and then of course I need to run separate loops for each type of an array, and it becomes harder and harder and harder as the application, complexity of the application grows. And it's just without this type of simple and direct approach that we used with using abstract method, it would be very difficult to both write code and maintain the code. So I don't think it's a big effort to actually follow the rules and just, you always write correct constructors, the constructors that you need, and make sure that you provide implementation for abstract methods. And remember that if you need abstract methods in your classes, remember to add them as abstract methods right here, in your classes. And that's pretty much all the game rules in this situation. So let's see what else we can say about classes. So here's another example with the product class defined as an abstract class, and it overrides the toString, but also provides another method which is abstract, and now we know that all derived classes, all subclasses will have to redefine this specific method because it's being declared abstract. Okay, by the way, here's something else I'd like to perhaps try before we move on. I'm going back to my project, and let me add a new class, which is I don't know, just delete me. It's not going to do much. You'll see why. So what I'm going to do is that I just added a class which I never use, right? The class name is delete me, which kind of suggests that it's pretty useless in this application, right? But it does not prevent me from building my application. Yes, there's a class named delete me and it's empty. But what if I made this class abstract, right? So what if I declared this class abstract and saved it and tried basically the same thing, clean and build? As you can see, this, and I can run it, so it still works and everything. So the creation of an abstract class in your application does not cause problems. It's just something to know that as programmers, you can't write 5 classes in parallel. I think you're focusing on one class, then another class, then maybe going back to the original class, then work on some other pieces, but you're always focusing your attention on a specific part of your application, and so it's just important to know that adding an abstract class does not violate any rules as you do something like this, unless you need to instantiate the actual instance. So, but let me add abstract public, right? Public void dummy method to this class, right? So once again, I have no intent of instantiating it, but I did add an abstract method named dummy to this delete me class, and still I believe that it should not be a problem to build an application and still run the application. The issue with abstractness of the class and the need to override its methods only arises when you intend to actually try using it or try deriving subclasses from it, and there, of course, you will be forced to provide the implementation of the concrete implementation of this abstract method. Otherwise, it's not going to compile. So just to let you know that it's not a very big obligation on your part until there is the actual situation where you need to use this class. Then, of course, abstract class you cannot instantiate. You have to derive a subclass from it, and then, of course, you also need to provide implementation for every abstract method. So something that I want you to realize that this is just the dynamics of software development, and it's very natural to define classes and make them abstract and add abstract method even before you try using them. Okay, so moving forward with this topic. So concrete class is the one that does not have any abstract methods, and therefore concrete class instances can be created at runtime, and we don't have a problem. And that's pretty much the intent of moving forward with inheritance that we use. Hierarchical relationship between classes when we use extend, right? So the book here extends from the product in this particular set of slides, and book has an author, and of course it will override the abstract method to provide the actual concrete implementation of that abstract method in its own body. All right, so moving on. Uh, to be complete on the specific topic, as we covered the syntax and usefulness of abstract, there's also final modifier. The final modifier is basically the opposite of abstract. Sometimes you go to your, class design diagram, and you can then create, another class. For the lack of good name, I'll just use, let's see, and maybe I can say price, something like that. And price class over here is not designed to be participating in any kind of hierarchy. So when you create this price class, so you can intentionally disable other programmers, including yourself, from deriving classes from this class if you declare this class a final class. So let me try a demonstration of this, right? So let's maybe go back to this little application and add yet another class, and I will name it how about product price, right? So somehow we have a class which has some intelligence on how to mark prices on items. This is fine. So we create this, and it goes into the same package. So let me just make it the usual decorations that I use when I write code. But here you can say that this class is not designed to participate in inheritance relationships, a relationship of any kind, okay? So what does this mean, of any kind? So what does this mean? You can basically say, I don't want people to derive their classes from this class. So you say final, okay? and this is the opposite of abstract. Abstract class essentially sooner or later will force people to derive subclasses from this from a superclass such as product, right? But in a situation like this one, somehow this design is not intended to be a participant of any kind of hierarchical relationship. You can make it final. So then if I say, okay, let me just go and create new Java class, or in fact, I can keep doing things to this delete me. If I intended to say extends product price, which is not the intended use, right? So let's save this and then go try compiling it and see what kind of error messages we get. So here what I get is an error, cannot inherit from final product price, okay? So intentionally it was made final, and final means can no longer be extended by anybody else. So that's one of the features, and therefore this feature right here is not available, and so I will just comment it out because cannot do that. The question is, where could something like this, like final class, where could something like this be useful? And the answer is, it can be useful in classes which are specific to particular areas of application. Maybe you're working with an implementation of a database of a specific vendor, and you find convenient to do certain types of work in certain types of classes. And this is something that you don't intend to distribute across, to other areas of your enterprise. You don't want programmers to modify this code in any way without you knowing it, right? It, because when we say extend, we can override the behavior and we can change the behavior. But sometimes you want to prevent that kind of change and say, well, you know what? If you need a change, you need to come and see me because I own this code. I don't want you to change it. You have to see me and we can then discuss it. And either I will let you make changes or I will make those changes for you, or we may decide not to make changes at all. And that can be enforced by saying final. Okay. So final can be, just like final can be used with the class, there are other usages of the final modifier. So it can be used with a class, just like we demonstrated just a second ago. It can also be used with a method, so that the method will be prevented from being overridden. By the way, as soon as you declare a class private, as soon as you do something like this, declare a class, I'm sorry, final, not private, final, all methods inherently will be made final in it, right? So as you declare class final, all methods by default will be final. And if they are final, then it will prevent people from overriding these methods, even if the class wasn't declared final on its own. And also you can do something like this, right? So I could have added, let's just demonstrate it someplace. We can have private void do stuff, right? Method. And this particular method actually takes an integer, we can say maybe a double price, right? Something like that, because it's product price. uh, we can say set price, right? Set price, and then we can say string product name, right, and then double price, so that it just makes some kind of sense to demonstrate some functionality inside product price class. But then what you can do, you can say you can say price equals zero point 0.0. So despite the fact that price is a parameter to your method, remember how parameters are passed to methods.